Okay, so now I hope you're ready to play the doppelganger game. And for those of you who don't know what a doppelganger is, it's basically someone that looks very similar to you, but they're not related at all. So the application that we're building is just a very basic, simple application. In my case, it's Angular, but you can do this in any other framework or without any framework at all. You just need a form, and then you need a file upload functionality where you can upload an image, and then an API will return you a percentage for a similarity with a 80s character. In this case, we can see that Burke looks 95% like Arnold Schwarzenegger, and then Sam here, who's an amazing Angular person, or not just an Angular person, but someone from the Angular community, looks 97% like Bonnie. And it turns out that Bonnie is her mother, so somehow the AI got it right. So then our next quest is this one. So by the end of this talk, you're going to find out whether AI finds Peter and Matthias to look similar. Are you excited about that, Peter? Yeah? Awesome. We're going to have to wait for that, though. So my name is Simona Cotin. I work as a developer advocate at Microsoft. You can find me on Twitter at Simona_Cotin. If you have any questions about JavaScript, Azure, Node, anything really, ping me. I'm happy to chat with all of you. So let's enter episode 1, which is not working. But this is basically a poem that has been generated by AI, by Google AI, and it's been fed like thousands of unpublished romantic novels. And if this would have worked, basically you would have seen that AI has used, generated a poem that's not necessarily the happiest poem in the world, which makes us wonder, like, what's our perception about love? But that's a completely different story. And now it's working. So you're right, oh, right, you're right, okay, fine, yes, right here, no, not right now. This has been generated by just receiving like 2 words, and then it's used the previous data that has been fed into the algorithm to generate this entire poem. The next thing that's super interesting is this project called The Next Rembrandt. And you can see here we have 2 pictures of Rembrandt, and one of them has been generated by AI, and the other one is the actual original Rembrandt. So who here thinks that the picture on their left is the original one? Yeah, there's a couple of hands here, maybe a quarter, 20% of the room, who here thinks that the other picture is the original one. Oh, more people. Okay, so you're better at this. But yeah, turns out that the picture on your left has been generated by AI, and we've basically fed like more than 300 of Rembrandt's paintings into this algorithm that figured out what's Rembrandt's style and what are some of the features and style that he uses to paint. And then it has generated this model, which has been printed by 3D. So that's super exciting. So AI can generate paintings. AI can generate poems. AI can also help us with pickup lines. You are so beautiful that you know what I mean. I want to get my heart with you. I want to see you to my heart, and you look like a thing, and I love you. If we were to leave this to AI, I'm not sure what would happen, but this is something that a scientist has basically used machine learning to generate pickup lines, and you can find the link here to learn more about it. But seriously, machine learning is everywhere. It helps us with our search engines. It basically figures out which are the results that might look best for us and we might be interested in. It also helps us with self-driving cars in the future, hopefully, with all our healthcare and how we identify some of the diseases that we might have or we have. And machine learning is absolutely fantastic. It's really great. It helps us, and I think it's gonna take over the world, definitely. But like a simplistic definition, whenever we're building applications for machine learning, we're basically kind of teaching computer to learn with data without being explicitly programmed. And in a machine learning versus traditional computing type of context, because puppies are so very popular, what would be the characteristics that we would use to kind of understand whether we're looking at a puppy or not right here? We would look at things like, does it have 2 eyes? Yes. Does it have ears? Yes. Does it have 4 legs? Yes, perfect. This is a puppy, maybe. So we would use if and else. Whereas with machine learning, we're most of the times we have to use multiplications and operations on data. And it helps us identify things like this, where we kind of, as humans, it's easy to recognize this. But imagine a computer or having to write if-else statements for this. That wouldn't be an easy job, or even worse. So this is what computer vision helps us with, like kind of identify those edge cases where we can see whether a chihuahua or a cookie is a chihuahua or a cookie. There's other good things that we can do with machine learning. This is an application that has been built by my colleague, Sarah Dresner. And she basically built an app that uses an API to auto-generate alt text for our images. So basically make our websites much more accessible, friendly. And that's something we should all aim to build while we're developing stuff. And there's tons of other things we can do with machine learning. So I've mentioned vision, where we can basically classify images, or we can find out patterns in images. With language in machine learning, we can translate words, or we can maybe speech. We can convert spoken audio into text, and then we can use even search and knowledge for mapping complex knowledge. So there's a lot of things that we can do with machine learning that help us in our day-to-day life. But today we're going to build a doppelganger app, because that's a fun project to work on, and it just gets us started with machine learning. So basically, we have this machine learning algorithm, which in our case will probably be deep learning with convolutional networks, and that's something we're not going to get into today. But most of the times, we have some data, we feed that into a machine learning algorithm, which creates a model for us, and then we give that model new data, and that's going to help us predict new results. So our goal is to train a model that will match faces to 80s characters. And in particular, you can see here in an image that I look 31% like Back to the Future. That was one of my early iterations, which basically meant absolutely nothing. And that can happen. That's fine. So the first step really is to kind of prepare our data. So what we need here is 80s faces, which we're going to get from pictures. So I've kind of made a list with all the movies that I might like from the 80s, and started downloading pictures with all those characters that I want to have in my application. And then the second step was to basically start running and training that model with those pictures and iterating there, because we're training this, we're seeing results. Is the performance of our model okay? If it's not, I have to find new pictures with better quality so that the recognition happens at a better accuracy. And then the third step is actually, once our model is correct, we have to deploy it somewhere so that I can use it and other people can use it. There's tons of tools out there that we can use. TensorFlow is one. The one that I focus on, because it's most familiar to me, is the Custom Vision Service from Azure Cognitive Services. And it's basically a tool for building custom image classifiers. And the one thing that I love about the Custom Vision Service is that it has used all these images that have been uploaded on the internet by everyone and have been searched by everyone and tagged, and it has used all that knowledge so that now it can help me build on top of that and recognize objects in images and run machine learning on certain models. So I'm going to try to demo. Hopefully, not all of you are using internet right now. It's going to be a live demo. Because my goal here is to show you how easy it is to get started, at least with a fun app and machine learning. So fingers crossed. This is a dashboard, so this is where Custom Vision API, we can access it. And these are some of the projects that I've created in the past. So now if I want to create a new project, I have to log in, and then I need to enter a project name. So naturally, this would be node.conf.eu. And then it will ask me what kind of domain do I want to cover. So you'll see there project types and classification types. We don't really care about that one. But when it comes to domain, for example, if you're going to build the typical not a hot dog application, you're probably going to want to use the food domain, because that means that the pre-existing model that we're going to use for this application is actually trained on a lot of food pictures. So it will perform so much better. In my case, there is no domain for 80s characters, so I'm going to have to go generic and hope for the best. So I'm creating a new project, and this will take me to a new dashboard where I can upload pictures so that I can train my model. And there's a couple of requirements here. The first one is that for each project, in order to get started, you need at least 2 tags or 2 sets of pictures. So I hope that there's a couple of Star Wars fans here. So we're going to start with Leia. And we have to tag our images. So this is our training set. And this is the data that the algorithm is going to use in order to recognize new images. And to tell me whether the picture that I'm testing against is more similar to Leia or to any other tag that I'm going to create. So I've uploaded here a new picture I've uploaded the pictures for Leia, and now I want to upload the pictures for our friend Luke. And I also want to add this tag. And as you can see, it takes only a couple of seconds, which means that the internet is being very friendly to us, and you're not all using all the internet in the world. So we've uploaded a couple of images. We have tagged them. Now the next step is, remember in the steps that I highlighted there, we have our data set. The next step is training our model. And this will take a couple of seconds as well, depending on the number of pictures you have uploaded. The more you upload, the longer this step will take. But at the same time, the more performant and accurate your algorithm is going to be. As you can see here, this has never happened before. We are being very accurate. So accuracy is something that we can use to understand whether our model is going to be able to recognize correctly images. And there's 2 metrics here that we're interested in. The first one is precision, and that's basically telling us of the pictures that have been classified as Leia, how many actually are Leia. And then the other one is recall. Does my algorithm remember pictures correctly? Of the pictures that are actually Leia, how many have been classified correctly? And the aim is to have both of these numbers kind of aim towards 100%. And we can see details here like the precision for Luke is 100%. The recall, on the other hand, is only 83%. And we have very small recommendations here as well. Like, for example, in order for this algorithm to perform well, you're probably going to have to upload at least 50 images. But a more realistic use case is where you have probably 1,000 images or even more. And you can find a lot of that data online. Kaggle is a tool that's being used by data scientists a lot, where you can get information about, for example, movies or any other kind of data sets that you might be interested in. But the next thing that I want to do now is go ahead and run a quick test. where I can actually use the model that I've just created and use Burke's image to test this model. So we can see here that Burke looks 61% like Leia. Not sure if he's happy with that, but definitely that's what our model thinks. So we can already see that it's not performing great. And the two reasons for that is that we don't have enough pictures and we don't have enough tags. So there's only two options there. Burke can only look like Leia or like Luke. And in this case, it's Leia. Another cool thing that we can do here, so we've trained our model. So the third step was deployment, right? And here we can see this prediction URL button. And what this will give us is a REST endpoint, which we can call with either an image URL or an actual image and get results. Just like we ran that quick test within the dashboard, we can actually take that URL in our client app, like our Angular app or React app, and run the exact same test and get the exact same results. And this was only maybe 5 minutes. You just have to have the right data, which is not an easy feat. Yeah. So I think this is all of our demo. I've also pre-recorded all these steps so that in case the internet is not OK with us. I'm just going to repeat this so that it makes sense. So precision. Of the pictures that have been classified as Luke Skywalker, how many are actually Luke? And then recall of the pictures that are actually of Luke Skywalker, how many are classified like Luke? OK, so then I mentioned Angular. How do we use this endpoint that we've just created in Angular or any other client app? All we need is a URL. And then we also need a key that will authenticate our app to that particular endpoint. And we need to send the image. And then we're going to have access to that particular model. And we've achieved our goal. Sam looks 95% like her mom. Fantastic. But as you've seen there, I've done a lot of manual steps, right? I've searched for images manually, I've downloaded them, and then I've uploaded them, which sounds like kind of waste of energy. The tasks that we would have in order to automate this would be to get a list of URL for each of the tags that we've decided that we want to create, and then also send that list to our model to train on. And because I'm using cognitive services, you will see here that I'm using the Bing search API to retrieve a list of images. And this is going to return a JSON object that contains properties for those images, like the URL, but also some of the landmarks for the faces, probably, no, not right here, but properties for those images. So cool, I can use that. Instead of downloading the pictures myself, I can actually automate myself out of a boring job and just call an API. And I can do the same for training training our model, because if I can use a prediction API endpoint, I was like, probably there has to be an endpoint for actually training all that data. It doesn't really sound that a person should have to upload thousands of images. That's an insane task, and nobody should have to do that, like, ever. So ta-da! We've already heard the talk about serverless, and I've given another talk about serverless last year, right here. And just a very brief overview here. So when we're talking about serverless applications, we're talking about applications that are either calling third-party APIs, or we're writing custom code that's specific to our problem. So in my case, I'm calling APIs like Bing Search API and the cognitive services for training our model. And then I'm also writing custom code that allows me to automate the tasks that I need to do manually. And serverless is absolutely fantastic at both those tasks. And just 3 things that are really important about serverless. we need to react to events. So serverless listens to events like an HTTP request or a message that has been uploaded on a blob or a file that has been uploaded on a blob or a message on a queue. It auto-scales, so we can go from maybe one request that searches for a single image to like a million requests that searches for a million images. And that's great for us because it allows us to kind of find a lot of data for our model. And then we pay as you go. It's a fun project. I don't want to pay a lot of money, and serverless allows me to do that, enables me to do that. So this is kind of the schema of how we would go about automating those tasks. We start by adding a message on a queue. In this case, let's say Lorraine Baines. And having that message sent on a queue basically triggers a function to run that will call the Bing Search API. And then once we get a result back with all the URLs, with images for Lorraine Baines, then we add those URLs on a different queue, and then we run a new function that will train our API. Are you still with me? Yeah? Cool. So this is the code for it. It fits on a screen. It's much faster than me uploading or searching for pictures. We basically call the Bing Search API right there. We set a string search right there, which comes as a parameter. And then we send a key that we're retrieving from the process environment because we don't want to commit it to GitHub and all of that. And then in order to train our model, we do very similar things. We use a URL that we send the URL, we use the endpoint that we send the URLs to, and then we use a API key, and that's pretty much everything. We've automated ourselves out of a job. And to take this one step further, this is part of the Angular app where we're calling the prediction API, so to get those similarities. And you can see here that I'm actually using an access key directly in my code, in my Angular app. And that's something that's going to go on GitHub, and that's going to become public, and everyone will be able to use my API key. So instead of doing that, I can actually create a new function that I can call from my Angular app, add there the prediction API, and call directly into my function, into the prediction API. So once you start with serverless, everything becomes serverless. You want to solve every single problem with serverless. OK, so we're back to the question of the day. Does Peter or Matthias look alike? Do they look alike? So this is, who's this? Is it Peter or Matthias? This is Matthias. And this is what my algorithm says. It says that Matthias looks 60% like Arnold Schwarzenegger and 38% like Peter. So it's kind of close. But in reality, my algorithm is actually quite bad. So Peter, I'm sorry, this is not very accurate. I haven't used the pictures for movies from the 80s. They're not very high quality. And I didn't actually spend tons of time getting all that data corrected. So probably when you're going to try this at aka.ms/80s, most of you are going to look a lot like Arnold Schwarzenegger. But please do try it. It's going to be fun. You're going to love it. So just to summarize, I recommend you use serverless at least for fun applications and for side projects. It's going to enable you to develop things fast, and it's going to help you with all kinds of tasks that you might want to implement, including machine learning, automating maybe your model training, but also you can deploy your model into a serverless function, and that will make your costs go down, and it's fun. And then in terms of machine learning, I haven't touched any of the AI for good because it's a huge topic. But definitely I recommend you get started with machine learning, even with with platforms that enable you to create easy applications and maybe use APIs. And after that, kind of try to build applications that will make our world a better place. Some of the resources that you might be interested in are the applications that I've created, but also links to Azure Functions and the Custom Vision Service API. Yeah, thank you so much.